So we are going to go on to section 2 of chapter 3. And in this section, we're going to name ion compounds. Ionic compounds are going to be totally different than what we learned because we're not going to use just the molecular formula. We're going to use the empirical formula. Remember the simplest ratio. And the reason we do this, as you can see in this picture here, is that ionic compounds, ionic means charged. That means they either have a positive charge or a negative charge. They do not combine in definite ratios or definite numbers of atoms. They combine in ratios. And so here we have table salt. You have one sodium ion to one chlorine ion, and they hook together. And they hook together thousands and thousands of these sometimes, and these are crystals, and they turn into salt crystals because sodium chlorine is a salt, is an ionic crystal. And so that's what we're going to talk about, those ions. And they combine in definite ratios, as I said before, of cations. Always the first formula here is going to be positive, and the second is going to be negative. So it's going to be a cation. Cat meaning positive. He's a Cheshire cat, positively smiling, right? And then onto the anion, or which would be the second negative with the N in it, anion. So anion and cation right in a formula. So we're going to know that we're going to have the cation first, and now we need to know the numbers, how they're going to combine their formula into the smallest division. So we can see the smallest division of these two is just 1 to 1, right? But now we're going to find a lot of different variations, and we're going to have some polyions that form together, and then they're negative and they form on. So it gets a little complicated. The formula unit can be thought of as the smallest division of an ionic compound. So let's go on to the next here. So this page is pretty important because they want you to memorize this page, and it's kind of hard to do, but as you go through and you deal with these, you'll find out these here are polyions, like, because you see here there's nitrogen and hydrogen, and this forms ammonium. So let's look a little closer at that. You see there, and you see the ammonium is NH4, and it has a positive ion of +1, means it's a cation. So you see in the next below there is copper, and copper has one positive, and hydrogen has one positive, and potassium a positive, silver is one positive, and sodium. So those are all one positive. We're talking about the cations. As we go down further, we have calcium is always 2, has a charge of 2, and then these are really easy to find out. When they have a Roman numeral here, that means how many charges they have. So copper would be 2+, iron would be 2+. Fe2. Remember, Fe means iron. Lead is Pb, and it'd be 2. Now, the reason they put 2 there, because some of them have another charge with them, you know, so they might have a 3, so that this means what charge they have if they have a different charge. Mercury here, we see mercury having 2 charges, and onto mercury 2. So, well, mercury 1 actually has one charge, that'll be 2+. And mercury 2 has 2+. So the reason this is charged is because there's 2 mercuries with 1. So you have a 1 charge, but there's 2 of them. Now here you have mercury with a 2 charge. Tin with a 2. SN is tin. That's probably didn't recognize that one. But there's 2 charges. 2 means 2 charges. They have 2 charges. Zinc, 2 charges. These are all 2 charged polyatoms. If we go down further there, we have aluminum there, and it has a 3 charge, right? So 3 charge, and then we have iron having a 3 charge, and we go even lower here. See if maybe I better move this up. And we have lead, which is Pb is the word for lead, and you have 4 charges just by that number, 4, the Roman number. Tin will have 4 charges. So these here, they want you to know these. So if you don't know them, though, please come back to this, and you know, when you have a question, you know, okay, we can find out if I look on this table on page 40, right? So let's look up here at the common ions. Those are all our cations that have positive charge. Let's look at the ones here that have negative charge. So we have acetate, and it's an acetate. These are all, as you see with a negative charge, are usually end in ATE or IDE. So you can see, you can find out which ones, and they all have negative charges here. So acetate is going to be C2H3O2, and this is poly altogether. It's acting as one molecule, and it will hook on to another molecule like that. So, and here's bicarbonate is HCO3, and it's a negative charge. And we go down here, we have bisulfate is a negative charge. Hydrogen sulfate here, bisulfate. Bromide is a negative charge. Chlorate, negative charge. These are just ions here. Chloride, negative charge. Cyanide, SN, negative charge. Dihydrogen phosphate is a negative charge, with phosphate is PO4, this pretty big one. Some of these are kind of big, and the fluoride, negative charge. Hydroxide, negative charge. Iodide, negative charge. Nitrate, see the nitrate, NO3 is this whole thing together is a negative charge. And nitrite is another one, but look, this is O3, which is 3 oxygens, and this is only 2 oxygens. So these are ones that they're both negative charges. And permanganate there, and that whole thing that polyion has a charge of negative. These are just one negative charge, all of these. Now we go down lower and we'll see the 2 negative charge. So let's go lower. Here we go. The 2 negative charge, we have carbonate, has 2 negatives, 2 negative charge. Chromate, dichromate, hydrogen phosphate, oxide, peroxide, all of these, silicate, sulfate, they all, and then we have one only phosphate with a -3. Now, these are going to have to compound with these and balance out. Whenever you, and a lot of times they're going to hook together, but when they hook together, they balance out on how many of these ions you need for these ions. So we're going to get into this. So I just, this table is pretty important, because they're going to ask you, and you have to go like, what is hydrogen phosphate? Well, there it is right there, hydrogen phosphate. We just look it up right on the table. So you got that? So anyway, so the names of the ions, how they do, that names, that is pretty important. And some of them, as you see, are called polyatomic ions because they're made of a bunch of atoms, right? So let's talk about simple cations. So simple cations, basically simple cations. Let's go down here. We're going to names of ions, and it talks about simple cations down here. So simple cations. Okay. So they're formed by removing one or more electrons from the atom. And they're usually the name of the element. So simple ones would be basically not poly, they only have one. So you have, like, say that you have, see right here is magnesium here. Well, it has a positive charge. That's the magnesium ion. And some, as lead and iron, they have 2 different kinds. So they're not so simple. They have 2 different kinds. So some might have a one plus charge, and some might have a 2. To prevent confusion, these ions must include the charge of the ion, which is written in a Roman numeral. And I kind of went over there. Like iron here is 2. That 2 means it has +2. It doesn't mean how many ions, how many atoms are in it. It just means it has a 2 charge. And then here's iron 3, and it has a Roman numeral 3. That's how they do that. Let's look up here at your, see if I can, sorry. There we go, at this table, this top table here. So here we have chromium 3, means it has +3. Cobalt 2 has a +2. Cobalt 3 has a +3. Copper has a +1 because it has a 1 copper. 2 copper, 2 Roman numerals, has a +2. Iron, this is ferrous, which is iron. It has 2. And then an iron, the Roman number 3, has a 3. Mercury 1 has a, Mercury 1, basically here has H2 and H2 here, so it has a 2+, but there's 2 of them, so that's 1. And so now we have Mercury 2 has a 2. See the difference between here? This one is just 1, and this one's 2. Lead has 2. Lead 2 is 2. Lead 4 is 4. Tin 2, SN is 10, so 2 plus, and then 10 like that. So let's go up there, look at the ions up here. Older systems, okay? Basically, the way it used to be is that they would call this number 3 would be chromic, meaning it has 3. Cobaltus has the lesser one. Ic means it has a lot. Us, O-U-S, mean it only has a few. So here's cobaltic, and this is coprous, which coprous means it has a lot. And then ic means it only has a few. Ic means it has a lot, and coprous has a few. But see how they did there? This is the way they used to do it. So now they use the Roman numerals so you won't get mixed up. So you're going to be using the Roman numeral to find out how many charges it has, okay? So these are going on to, these are all simple. Remember, they don't look like, don't look like these, right? They're just very simple, but they have a number by them, a Roman number telling what their charge is. Okay, so let's see, let's go on. Just remember down here it says, okay, this table down here at the bottom, there we go. So here are the names for simple ions. Oxygen would be the oxide ion, and then the nitrite would be the negative nitride. Sulfide, that would be sulfide. Iodide ion, see all these ions? Selenide, just go down here and you'll see. So these are some names for simple anions. Remember we talked about the simple cations, which are positive. These are the negative ones. So, and you'll see how when we start naming these, you'll recognize this. Naming ionic compounds. So you see here, so naming an ion requires only naming the ions that compose it. No prefixes are used. Remember, like di, tri, tetra, they're not going to use those. The name of an ionic compound consists of the name of the cation followed by the name of the anion. So it's going to be easier in that way. Whether the compound is binary, made up of 2 elements, or composed of many elements, polyatomic atoms, the procedure is the same. For example, the household baking soda is this, which consists of equal numbers of sodium cations, here's sodium, there's sodium, and bicarbonate, which is this part, which is bicarbonate anions, which looks like this. This is sodium bicarbonate. The following are other examples. So you see there, kind of important that you know, kind of look at these examples. Sodium, this is sodium is Na, sodium hydroxide. Calcium, carbonate. Potassium, cyanide. Copper 1 means it only has 1 because chlorine only has 1, so it's copper chloride. This is ammonia. This is the polyelement ammonia. Nitrate. So these are 2. This ion here is totally positive, and this ion here is totally negative. Magnesium hydroxide. Magnesium has a +1 plus, and this has a 2 plus, so you have to put this in parentheses. Always put it in parentheses if you have more than one, you have a poly means more than one atom there, and put it into, then put the number at the bottom. So that's pretty important. So naming. The charges of simple cations. So when naming ionic compounds containing an element that exists in more than one catonic form, the full name of the ion according to stock system must be used. So 2 sulfates of copper would be, okay, let's go down and show you this here so you can see what I'm talking about.